Our last aspect of capacitor is the energy density in the parallel plate capacitor. Check it now. Energy what? Density in parallel plate capacitor. Well, I said we have different type of capacitors, but our interest in this class is parallel what? Plate capacitor. So can I say what? This can be defined as energy per unit volume per unit what? Volume V energy E per unit what? Volume of the parallel plate capacitor. So mathematically, we can have it in this form. Mathematically, we can have what? Energy U. We used to denote energy here. To denote energy density. Sorry, energy what? Density. We use U for denotation is energy per unit volume. We have energy stored in capacitor over what? Volume. V. E. Yes. We can now say what? Recall that what is energy? E is half of CV square. And the volume also what? Area times what? Height. So we can now have what? U, which is energy density. This will be what? Half of CV square. Everything over what? A. This A we have here, area of the plate. This height is distance between the two plates, which is what? D. Let me put it in what? In that way. If we can get to this side, we can still what? Recall again from, let me say what? Recall that what? Electric field intensity E is equal to V over what? Over D. From this expression, we can have V equal to the what? E D for the what? For this V. And if we agree that this is this, and again, from the parallel plate capacitor, from parallel plate kappa what? Capacitor, we have C should be equal to what? E naught A over what? Over D. Let's substitute for this D, C and D in what? In this formula. By substituting for C and V. So our what? Our energy density U. The energy density U will be equal to what? Substitute. We have half into what? What is the what? C. C is what? E not A over what? Over D into bracket what? What is B? B is what? Is electric field intensity multiplied by what? Distance D. Everything square. Then we have over. Over what? Division. Division we have there volume, which is what? A what? A D. So that's what we have there. And the next thing is we need to what? To expand. By expanding this, we are going to have, yes, the U will be half. So let me say, remove this half out. Half of the half E not A, good, over what? D multiplied by A what? AD, and E will give you what? Square D square. By continuing the what? The expansion, we are going to have what? This A will cancel this A out, and this D will be what? D square. We have U, the what? Half of what? E naught over what? D square into bracket E D square. This will also kill this. At the end of the day, energy density will be equal to the what? 1 over 2 E naught over what? E square field intensity what? Square. No, sorry. This will be T times what? This. It will be electric field intensity times what? E what? E square. Therefore, energy what? Density in parallel plate capacitor, which is what? U, is equal to half of what? Permittivity of free space E square. So this is the formula for energy what? Density. So the last aspect now. So note that this E is what? Permittivity of free space, which is what? 8.85 times 10 to the power minus, and E is electric field intensity. So the last one is force in the parallel plate capacitor. To determine the what? Force in parallel what? Plate capacitor. So this is the last aspect. If you could still remember, you will observe that what? In the parallel plate capacitor like this, we have a plate like this. We have the second plate like this. And I say we have positive, 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 negative, negative, negative. Good. And between them here, this is the distance what? D. Abi? And we have a wire that connect them to what? We have wire that is connect them to what? To the circuit. And don't forget that I said we have this thing at the middle. We serve as what? What do we have in the middle here? We serve as what? Dielectric material what? Material. And don't forget that this is what? This is the positive charge, this is the negative what? Charge. And is a must, there will be a particular force here, which is draw this thing together like this. This is the force, draw this thing together. The force in the middle here is called force of attraction. That is the force I'm going to what? To look for here. So I've know the what? The energy density and the energy stored in it. So let us know, look at the what? The force. So you can see that what? The force that exists between them is the force of what? Of attraction to the two charges. So how are we going to what? To determine the what? The force now. So you can now say what? The force can be determined from work done equal to the force F or multiplied by what? Distance D apart. So you can split this thing to F times what? Times D. And you can now say what? Recall that what is work done? The work done is equal to what? Half of CV square. Substitute for the work here. We have half of CV square equal to the what? FD. And again, we can also recall that I want to remove V. E equal to the what? VD. From this expression, V equal to the what? ED. So let's substitute for what? For this V here, sorry. We have 1 over what? C. What is my V now? V is what? ED, everything square, LD. By open the bracket, we have C equal to the what? E square, D square equal to the what? LD. Good. And again, we can also introduce that recall from parallel plate capacitor that this C is equal to the what? The formula for parallel plate capacitor is equal to the what? E naught A over what? Over D. Good. If is that the case, I can now put substitute for what? For my D. C here, I will have what? 1 over 2. C is what? E naught A over what? Over D into the E square D square equal to the what? D. So by doing this, so I thought this D will cancel D here. Second one will cancel by what? By this. You are now left with what? Half of what? E naught A D square. Everything is equal to what? F. So by doing that, we can move towards the force F will be equal to what? Half of half of what? What am I call it now? Hmm, half of half of E what? E naught electric field intensity square A. This is what? Force. And again, we can also set where what? The energy density U equal to the what? Half of what? Electric field intensity, no, probability of free space, field intensity is what? Square. By doing that, you will now have what? The force parallel in capacitor to be F. You will now have U A. Therefore, the force that is what we have between the two parallel plates is the product of is the product of energy density and what the area A of the what of the plate of the what area A of the plate. Can I say what where U is what is energy density, what density, and A is the area of the plate. Therefore, the force of attraction here is the product of energy density and the what area of the what of the plate. That is all about capacitors, which is known as what condenser for this level. Please don't forget to come to like, comment, share, and subscribe to my channel. Thanks for watching.